This is CET236, and this is the second question in the second in-class tutorial paper for fall 2019. So here we've got what appears to be a circuit with three meshes rather. There's one here, there's one here, and there's one here. And let's go through the mesh analysis algorithm. So first of all, let's change color. And because I have this current source here, I'm going to choose I1 to be going in the same direction, right? So there's I1. And then I also have a current. The question's asking me to solve for Ix. And Ix is down here. So I'm going to choose my currents in the two loops, in the two meshes that go through Ix to be going in the same direction as Ix. So let's go with blue. And so for this one, we're going to go around this way for I2. Right? And then I'm going to change color again and maybe get a green color. And I'm going to go around this way for I3. Okay, so now because we're going around this way for I3, that means this passive device has a plus sign there and a minus sign there. This active device always has its plus there and its minus there. Let's go back to blue. And we're going around this way, so this resistor R2 has a plus there and a minus there, and R3 has a plus there and a minus there. And then going back to I1, we have a plus on this side of R1 and a minus, and we have a plus and a minus, right? And it doesn't matter that the polarities on R2 are different for I1 and I2, it'll all come out in the wash. So now, this started looking like three loops, three meshes, so three equations and three unknowns. But because we've got this current source, right, that is only taking part in the I1 mesh, it simplifies out. So we don't have to do a KVL equation for I1. We just have to say by inspection, or by KCL, if you like, I1 is equal to IS is equal to 400 microamps. Okay, so that's 400 microamps. Okay, so that's sort of KCL for mesh 1. And let's go to blue, maybe. There we go, blue. So blue, we've got the KVL, because we don't have any current sources, for mesh 2 is R2 times I2 minus I1 plus R3 I2 minus VS, right? Because we're going into the negative side, even though I didn't draw it there. We don't change the polarity of the active source. Okay, now filling in some numbers for that, we get R2 is 4700 times I2 minus I1. R3 is 3900 times I2, and VS is 12. Okay, so that's 4700, so it's minus 4700 I1, and I2 it's 8600. So plus 8600 I2 equals 12. So now we've got one equation. Now we've got to go through the same deal but with I3. So KVL for I3, and this one's pretty simple. We just get 4700 I3 minus 12 equals 0. Right, so that one is actually pretty good, because we don't get any other currents. We've just got a current in terms of I3. So that means that I3 is equal to 12 on 4700. And the units of that will be amps, but obviously it's going to be less than 1 because of the 12 on 4700. Okay, so that means we can substitute that. We don't get an I3, but that means now we've just got this one equation, the blue equation. So we can take our I1 value, right, and substitute it in here. So we get minus 4700 times 400, and I'm going to write it out in full, by 10 to the minus 6, so that's the number in amps, 400 microamps, plus 8600 I2 equals 12. So that means we get 8600 I2 equals 12 plus 4700 times 400 by 10 to the minus 6. And that means we get that I2 equals 12 plus 4700 by 400 by 10 to the minus 6 divided by 8600. And let's just go back to black to get our final answer. So our final answer is I1, and we actually need I2 and I3 to get IX, right? So I1 we already know is 400 microamps. I2 is this number, so let's just pull up MATLAB. And what was it again? It was It was 12 plus 4700 times 400 times 10 to the minus 6 divided by 8600, and this is I2. And it's just I2 times 1000, just to see I2 times 1000. So that's 1.614 milliamps. So let's just bring that back up. So I2 is 1.614 milliamps. And then I3 is this 12 on 4700. Let's just bring that up. So 12 on, let's just put it into I3. I3 equals 12 on 4700. And let's just multiply I3 by 1000 again. So it's 2.553. Generally keep intermediate values in for significant figures, 2.553. So I3 equals 2.553 milliamps. And now the final answer, IX, is equal to I2 plus I3. And that equals, let's just bring MATLAB back up one last time. So 4.167. So that equals 4.167 milliamps. Okay, and that's what was asked for. So I don't know, some people like to circle the final answer, particularly if the layout's a bit non-linear like I have it here. So 4.167 milliamps is what I get.